Okay, so bookwork, you guys had to do completing the square and a few more quadratic formula, and you were assigned page 545, numbers 23 through 26, and then 28, 31. That was a mistake. You were not assigned 31, 33, 34, 35. All right, and you guys should always check your odd answers in the back of the book. So that should have already been done. 24, here we go. X is equal to 3 plus or minus 3 square root of 2. That's number 24. Okay, of course, check your odd ones in the back. 26 is nice, okay, because you get two nice solutions. -1 and negative 21. So 2 solutions for those. Did we do 28? Yes, we did 28. 28, you should have gotten. This one you had a radical, so you would have, when it's simplified, x is equal to 1 plus or minus 2 root 3 over 3. Now notice that that's simplified form, okay? And then we jumped over to 31, which was odd, which you did not do, but it's odd and it's in the back of the book if you want to go back and practice it. Did you guys do 33? All right, 33 is in the back of the book. You did 35. You did 34, which had a theta in it. Welcome to theta. And mine don't ever look nice, but that's called theta, and that's a Greek letter. And you will see theta a lot. You'll see me do theta this way with the little swirly. Okay, or like that, or I'll just like put a belt on it, okay? But that's the Greek letter theta, and you should have just replaced it with an X or a Y or any other letter, but it ended up giving you one solution. 3/4. And then I think you did 35, but it was odd and it was in the back of the book. Okay? Are there problems that you need to see from the book? Plus or minus 10. Let's look at 26. Of course, pause this when you need to. X squared plus 22x plus 21 equals x. And folks, we're completing the square, so automatically what needs to move? The 21's got to move to the other side, okay? Now, I'm going to rewrite that with my little blank, because I like my blank. But it's going to be 0. How do I mathematically move the 21? I subtract it from both sides, and then don't forget to add your blank. If you've got a blank on the left, you've got to put a blank on the right. And then, now we're ready for our process to begin, okay? I bring down an x. I bring down what? A plus. What's half of 22? 11. 11 squared is 121. If I add it to the left, I have to add it to the right. And then negative 21 plus 121 is 100. This one ends up working really nice because when we take the square root of both sides, that gives us x plus 11 is equal to plus or minus 10. We don't have a radical in our solution. It's a perfect square, so it works out nicely. Now, I would do this, pardon me? Okay. I would subtract 11 from both sides. And now I'm going to break this down every time. I cannot do this in my head because if sure as I do this in my head, I'm going to make a careless mistake, and I don't want to do that. So I've got x is equal to negative 11 plus 10. X is equal to negative 11 minus 10. And we're going to have negative 1 and negative 21. So both of those answers are solutions to that completing the square, which means our parabola crosses the x-axis how many times? Think about what we're doing. It crosses it twice. Where does it cross? At negative 1 and negative 21. Okay. What would the factors be? If our solutions are negative 1 and negative 21, then our factors are x plus 1 and x plus 21, right? Those are our factors. You don't. I'm just trying to bring you back to what we learned last semester in Algebra 2. Okay? Any other questions on the bookwork? 28. Let's look at 28. We got 3x squared minus 6x minus 1 is equal to 0. When I'm completing the square, what do I have to have my leading coefficient to be? I need it to be 1. So if it's 3, then I've got to do what? I've got to go through and divide everything by whatever that number is. That gives me x squared minus 3x minus 1/3 equals 0. That's right, a 2. A 2, because 6 divided by 3 is 2. Way to catch that. I did that on purpose. There we go. Here we go. Add that 1/3 to both sides. Y'all do not like, you don't buy that at all, do you? Okay. That was my one mistake made. It was made during first. I won't make any more today. Here we go. That's a lie too. X minus, because it's a minus sign up here, so we bring down a minus. What's half of 2? 1. 1 squared is 1. Add a 1 to the left, add a 1 to the right. Uh-oh, I got a fraction and a whole number. I'm going to change 1 to what? 3/3, because fractions are our friends. Decimals are the devil. Here we go. 1 plus 3 is 4/3, right? Square root of both sides. And then look what we end up with. X minus 1 is equal to, plus or minus, don't forget that when you have the square root of a fraction, that has to be broken down into the square root of the numerator over the square root of the denominator. That's going to give us, can I go ahead and add 1 to both sides? Sure. We'll add 1 to both sides. 1 plus or minus, what's the square root of 4? 2 over root 3. You ought to hear bells and whistles, okay? So you're going to have, we've got to rationalize that. We're going to multiply by root 3 over root 3, which is actually like multiplying by 1, which doesn't change its value. And now let's see what we end up with. X is equal to 1 plus or minus 2 root 3 over who? Plain old 3. Cool? Does that help? Yep, good. Did you find your mistake? Good.
You always just like, you have the square root of 4 multiplying the square root of 3 to both sides.
Yeah. Can you go straight from this step straight to that?
Oh, no, like without, like what I did is I didn't take the square root
of 4. Uh-huh.
I multiplied
Square root of 12.
Yeah,
and then you just had to simplify square root of 12. Yeah, as long as you simplify that. Absolutely. Yes, sir. Absolutely, you may do that. As long as you go and simplify at the end. I'm doing my simplifying early. You're doing your simplifying at the end. And that's fine. Totally fine. Other questions? 34. Let's look at 34. Number 34. With that theta, I'm going to go ahead and draw that theta in, because you guys need to become familiar with that. Fractions, fractions, fractions. We love them. Okay? Now, this is not where I want it to be, so I'm going to go on and rewrite. Plus blank is equal to 0 minus 9/16 plus blank. Do you guys agree with that? Okay? Just think of the theta as a variable. Now, we can do this. We got theta minus what's half of 3/2. We got to think. What's 1/2 times 3/2? 3/4, right? Oh, but isn't it much more fun to complete the square? Yes, it would be so much fun to complete the square. Hey, would I get the same answer by completing the square? I'd get the same answer, but I do need to follow the directions. So that means quadratic formula. Thank y'all. That's only mistake number 2, and it was made in first block as well. Here we go. Negative who? Negative 3/2. Bless y'all. We're just, that's right. See? Number 3. Here we go. Do not keep a tally on how many mistakes I make. Minus 4 times 1 times 9/16. Do you guys agree with that? Over 2 times 1. Is that right? Okay, lots of fractions. We are not scared. Negative negative is positive. Negative 3/2 squared. It's going to be positive 9/4. Do you guys agree with that? All right. Negative 4 times 1 is negative 4. Negative 4 times 9/16, I'm going to cross cancel. It's going to be negative 9/4. Do you guys agree with that? All right, so watch what is happening. What's happening here? My 9/4 cancel out. 3/2 plus or minus the square root of 0. Say what? What happens? Drop that 0 out of there. Do I need the plus or minus then? No. Now, that looks weird. What am I personally going to do to that? I'm going old school on that. There's nothing wrong with old school. I don't care what you think. Okay? Then copy, change, flip, and then look what we have. 3/4. So what's this parabola going to look like? It's going to touch the x-axis just in one spot, and it's a positive leading coefficient. So is it turned upward or downward? Upward. Good. Good, good, good. Look at that. Wow. Piece of cake. Can of corn. Okay, I asked you to do 6 through 12, right? Thank goodness. Whew. All right, number 6. You should have 16 over x cubed plus 5x squared minus 16. That's the answer for number 6. Make sure I went back and fixed that. Yep. Thank you, Zachariah, for helping me on that problem. Finding my mistake. Number 7. Check this out. Really? Look what you started with in number 7 and look what we end with. Are you kidding me? Isn't that insane? That is number 7. No, that's number 7. Number 6 is right. 16, it is. Promise. X squared plus 6x plus 36 for number 8. And then number 9 was factoring, okay? Now, here we go. There are 3 factors. The first thing you have to do is factor out a 5 for the GCF right off the bat. Then you're still left with 4 terms, and you group them, and you have 7b minus 6 times a plus 6. That is number 9. All right, because you can switch those factors around if you have 3 factors. Remember, commutative property multiplication says I can put the a plus 6 first and the 7b minus 6 last. That's all right. I could put the 5 smack dab in the middle if I wanted to. It doesn't matter because it's multiplication. Number 10. Number 10, number 10, number 10. Again, you got a GCF. Factor it out first, and it's 2. And then you're left with 4 terms, 4y plus 7, and then 7x plus 6. That's right. 2 times 4y plus 7 times 7x plus 6. Number 11 is just slide and divide. X minus 3 times 7x plus 5. And number 12, last one, factor out the GCF first and then slide and divide. 7b plus 8 times b plus 7. Stare and compare, folks. Look at your answer. Tomorrow we'll go over the test review. I gave it to you yesterday, and I said I'm not going to check it today. We'll go over those questions tomorrow. If you have questions, now we'll go over the homework that I assign you tonight, and then I'll go over the test review at the end of class tomorrow. You have a test on Friday, unit test on Friday, and it's everything we've covered thus far, okay? And if you've got that test review, then you know everything that will be on the test on Friday, okay? All right, we're going over something new today. I don't think you have ever learned this. I have never taught this. Nerd. Here we go. Solving quadratic inequalities. Folks, we have been dealing with solving quadratic equations. Now we are solving quadratic inequalities, right? So what we have done so far is we've been dealing with the quadratic equations. And remember, an equation has an equal sign, and inequality has a greater than, a less than, greater than or equal to, or less than or equal to. That's the difference. We kind of treat them the same. The only difference is the sign that's within that equation, if you will. And we have been dealing with these quadratic equations. We've been solving. What's the easiest way to solve a quadratic equation? Solve by what? Factoring. That's the easiest way, I think. And then what's the other way? We use it as a last resort. What is it? Quadratic formula. But the one good thing, it'll always work, right? Quadratic formula always works. What's the other way? Completing the square. Completing the square. All right, so those are the three ways, and of course take the square to both sides, but that kind of goes in with completing the square. Now, solving inequalities, a little bit different. What are we going to do? Well, we're going to solve the corresponding equation. Oh, dagnabbit. There we go. We're going to solve the corresponding equation. If I were to give you an inequality, and now this is just an example. This is not a quadratic inequality. This is clearly a linear inequality. How do I know this is a linear versus a quadratic? No x squared. All right, if I gave you this inequality to solve, we're not going to solve it. We're actually going to go over here to the side, and we're going to solve its corresponding equation. All we're going to do is just change the sign from an inequality to an equal mark, okay? Then we're going to make us a number line. And we're going to go back to an old school number line, that right there, okay? And we may have 3 or 4 little tick marks on there. And you'll see what we do with that, okay? Once we make the number line, we're going to test each solution. An interval. We're not going to check the solution. We're just going to check this interval. My fault. We're going to test each interval to see if we get true statements. Okay. We want true statements. We don't want false statements. And then we're going to darken in our number line. According to our solutions and intervals. He did? Okay. Okay. Good thing it wasn't on the SOS. Okay. Good. All right, so this is the first time I've ever taught it. I mean, I teach it every year in trig, but I've only taught it in trig. I didn't teach it in algebra 2. Maybe I need to go back and read the SOLs to see if I was supposed to. But anyway, those are the instructions. Whoops. Mistake number 4. Thank you for keeping tally. Here we go. So this is what you're going to be given. This is really, really easy. And we're going to start really simple. X squared minus 6x minus 7 is less than 0. Remember, if we're solving quadratic equations, we need our equations equal to 0, right? We want our inequalities equal to 0 as well. Now, let's take a little side. Let's take the off ramp, okay? We're going to the rest stop. Side note. Remember, when we use open circles on your number line, that's an open circle. We use open circles when we have a greater than or less than symbol, okay? We use closed circles, which are darkened in. What's different? Greater than or equal to. And let me show you how I remember. Because I don't know about you, but those stupid little things, who knows? How would you keep them separate? More ink, more ink. That's how I've already known them. They have more ink, so you put more ink. The signs have more ink, so the circles have to have more ink, okay? So keep that in mind. Now, we've got to solve the corresponding equation. So we're going to come over here to the side, and we're going to solve this equation. Are there 2 factors of 7 that when I subtract give me 6? 7 and 1, right? All right, so we got x and x, 7 and 1. Are my signs same or different? Different. Which one's going to be minus? 7. All right, now look what we got here. I've got my solutions are 7 and negative 1. Do you guys agree with that? All right, so that means when I draw I'm going to come over here and draw my number line, that I've got 2 numbers on my number line. I've got negative 1 and positive 7. Okay? Now, look at the sign above. Look at the inequality symbol. The inequality symbol is a less than symbol, right? Am I going to, is it going to be an open or closed circles? Open circles, because there's not a lot of ink there, okay? Now, intervals. We got to test our intervals. All right, this is just precursor. We're still preparing. What do I mean by intervals? I mean, give me a number, name a number to the left of negative 1. An easy number to work with. Negative 2 is a good number, not negative 45. What is a number, an easy number, between negative 1 and 7? 0 is an easier number. Attaboy. And what's another easy number greater than 7? 8 or 10. Always choose like a 0 or a 10 or a 2 or a 1. Choose, to me, that just makes sense. All right, so what are we going to do? We've got to go back up into the original inequality, and we have to test our intervals. So let's test 2. So I'm going to put it in place of x, and I'll have negative 2 squared minus 6 times negative 2 minus 7 less than 0. All right, now watch what I'm going to do. I've got to see if this is going to give me a true or a false statement. So let's do some little calculating. Negative 2 squared is 4. Negative 6 times negative 2 is positive 12 minus 7. Now this is all calculator work, folks. 4 and 12 is 16, minus 7 is 9. Is 9 less than 0? No. Will I darken in anything to the left of negative 1? No. Let's test 0. 0 squared minus 6 times 0 minus 7, less than 0. Okay, look at this. Common sense. Let's go just completely cancel out of here. 0, 0, because 6 times 0 is 0. Is negative 7 less than 0? Yes. Hey, what am I going to do between negative 1 and 7 on my number line? I'm going to shade it in. We got to test 10. We can't forget about it. 10 squared minus 6 times 10 minus 7 less than 0. What do you think? What do your bones tell you? Are they telling you that it's going to darken in or not? I don't think it's going to. I don't know, though. Let's see. And I don't trust myself, so I want to calculate. 10 squared is 100. 6 times 10, or negative 6 times 10 is negative 60. Minus 7 less than 0. That's 40 minus 7 is 33. Is 33 less than 0? No. Will I darken in to the right of 7? No. This right here, folks, is what I'm looking for. That's what I'll be looking for. Now, in addition to your number line, we got to think about interval notation. Yep. With one solution, then how many intervals will you test? One to the left, one to the right. You'll test. Yep, because it could be, the number line could be shaded in one direction or the other, or what if it were all reals? How would you do that? You'd shade the whole thing, okay? And we do come up, sometimes we're going to deal with those cases where it's all reals, okay? All right, let's talk about interval notation. Now this definitely prepares you for math analysis and or calculus. I don't know that this is, I don't remember, just to be right honest with you. I don't remember if I taught this in Algebra 2 and or trig, so I don't remember. But interval notation to me is how I'm going to reflect that number line using mathematical symbols. Does that make sense? I'm going to use mathematical symbols to reflect what I see on this number line, okay? So if I have open circles, then I want open circles and or infinity. I have to use parentheses. Sometimes you'll use both parentheses. Sometimes you'll only use the parentheses on the left. Sometimes you might only use the parentheses on the right, okay? But that means if you use it, that value is or is not included. If it's an open circle, is that value included or not? No, that value is not included. I cannot, This is like the discontinuous graphs, the discontinuous functions that had the holes in the graph. Remember those? That's what this is like. If I try to put my finger on that line that has that hole in it, and I do that, that's not going to work. That's not going to work. Let's look at the closed circles. So if I use parentheses with open circles and or infinity, I'm going to use closed circles. Closed circles, we're going to use square brackets. That means that the value is included. Okay? Interval notation, it's weird to begin with, but then you're like, oh, this is a piece of cake. Now, infinity is that thing. Folks, can we ever literally touch infinity? If I get closer, if I take one step closer to infinity, what's infinity going to do? It's going to keep stepping away, and I'm going to step one step closer, and it's going to keep going, right? I can never reach infinity. So I think of it like I can just hug it. Little, you know, like one of those little tap hugs. Y'all know the people that you just like, they'll go, hey, how you doing? And they come up to you and you're like, hey. And then they all up on you giving you a hug, and you just like, you like stiff as a board. Hey. And they still hugging on you. You know the people. You know those people. We may have some of those people in your classroom right now. I don't know. But infinity is that type of person. They just they loner. Just leave them alone. You can't get them. You can't reach them. Nobody can reach them. Mr. Infinity. He is the man. He's kind of bigger than Chuck Norris. I'm just saying. And or the man on the Dos Equis. Is that how you say it? The beer commercial? Dos Equis. He cracks me up because he's like on the same level as Chuck Norris. All right, this is going to be a great recording for second and third block. Here we go. Infinity, hugging people, beer commercials. It's great. All right, we're not done. We're still not done because we got to get back in the car and get on the interstate. Here we go. How am I going to represent that number line using interval notation? Please don't don't encourage your parents to watch these recordings or listen to them. Indy, I might be talking to you. What am I going to do? That's an open circle. So is that going to get a parentheses or a bracket? It's going to get a parentheses. Check this out. The interval notation for this graph is going to be parentheses, -1, comma, 7, parentheses. Now that looks like an ordered pair, doesn't it? But it means that -1 is not included, but the values between -1 and 7 are included. 7 isn't included either, and that's why I use the parentheses. It's basically -0.00000000009 to 6.99999999999 cos. Because it's going to -1. So what about those values? -0.9999999. You're right. I'm wrong. Number 5. Stop. Number 5. All right. Here we go. Let's look at another one. It will make sense when we do it all without the little side notes. Here we go. X squared plus 9x less than -14. What do we have to do? I got to set it equal to 0, right? So x squared plus 9x plus 14 is less than 0, correct? All right. We've got to solve the corresponding equation. X squared plus 9x plus 14 equals 0. Yes? 7 and 2 plus and plus. Do you guys agree? Yes or no? Yes. The solutions for this equation, they are -7 and -2. Right on. Y'all with me? Okay. Got it? All right. What now? Graph it. I got to put it on a graph first, and that's going to help me determine my intervals. All right, so, hey, by the way, are these going to be open or closed circles? Open. How come? Because it's a less than symbol, no line underneath, right? So intervals, what are my intervals going to be? Let's choose a nice number. -10. That's a good one. Do you agree with that? Could we all choose different numbers and still get the same end result? Yeah, as long as they fall within those parameters. Here we go. Ted, you go on and use your -8. I know you want to. So let's test. Now, I'm going to test -10. This is the pain in our hind ends, okay? Because you got to do all this extra work. What the crap? When you test, you can do it here or here. Because that second one is just a variation of the first inequality. I just moved things around, that's all. Okay? It would be easier to plug it into the first one. Sometimes it is. I'm going to plug it into the first one this time. X, or -10 squared plus 9 times -10 less than -14. Let's see what's going to happen. What's -10 squared? You better tell me positive 100. 100 minus 90 is 10. Is 10 less than -14? No. All right, so we're not darkening in over there. You guys with me? Let's try -4. Again, I'm plugging into the very first inequality. My second one's just a variation of the first. -4 squared is 16. 9 times -4 is -36. What's 16 minus 36? -20, right? Is that right? Is -20 less than -14? Yeah, it is. Oh, what's that mean? Aha, I got to shade it in. This is going to work. Yes. Shade it in the middle. What do you think is going to be the case for 0? It's probably not going to. It might, but let's check it. We can't assume. Look what's going to happen. 0, 0. Is 0 less than -14? Nuh-uh. So, we've tested all our intervals. Now let's go back close to our number line. And I have to write this in interval notation. Okay? Here we go. Parentheses or bracket at -7. Parentheses, -7, comma, you tell me the rest. -2, parentheses. This is what I'm checking for, y'all, this right here. I want to see that number line, and I want to see your interval notation. We will use those numbers. They might not always be in the same bracket or parentheses, but we will always use those numbers unless it's that case of all real numbers. A whole number line shaded in, and instead of I'll show you another way you could write that too. There is another way to write all reals. What? Oh, the double R looking thing? Yeah, you can do that, but I'm going to show you a different way to represent it using interval notation. Think about what all reals means. What does that mean? Every single number, every possible number. For example, what a beautiful segue to the next example. Wonder what this answer is going to be. Here we go. Check this out. X squared plus 6x plus 9 greater than or equal to 0. Corresponding equation. Give me 2 factors of 9 when you add, give you 6. 3 and 3. Plus and plus, right? What's your solutions? There's only one. Well, there are 2 roots, but the solution is -3. Do you guys agree with that? Huh? It's a double root because you see 2 factors that are the same. Very good. Number line. We got -3. Now, this is what you were asking about earlier. First of question. Are you looking at it from a forest perspective? Maybe. Did we factor it correctly? We're solving the corresponding equation. We've got 2 factors of 9 that when you add give you 6. We've done that. Okay? You're looking at it from a forest perspective. I'm still in the trees. I'm up in the limbs. Okay? Will this be an open or a closed circle? Why is this closed? Because it has a line, more ink, so more ink. Okay? Now I want y'all to think about this. Now we're going to choose our intervals that we're going to test. What 2 numbers? How many intervals do we have this time? This time we only have 2, 1 on each side of the solution. Where's 0 going to be over here? What's the other one to the left of -3? -4, -5. I mean, it doesn't really matter at this point. I'm going to put -5. So let's test. Test -5. So I've got -5 squared plus 6 times -5 plus 9 greater than or equal to 0. 25 minus 30 plus 9 greater than or equal to 0. That's -5 plus 9, which is 4. Is 4 greater than or equal to 0? Yes. Okay. That means I'm going to shade to the left, correct? And if you shade it to the left, folks, darken in that arrow. Just do that to humor me. Let's test 0. Everybody with me so far? All right. 0 squared plus 6 times 0 plus 9 greater than or equal to 0. 0 plus 0 plus 9. Folks, is 9 greater than or equal to 0? Yep. Okay. Go back. Let's shade that in. Okay. Oh, look. Our whole number line is shaded in. What does that mean? It's all real solutions. I could do a couple of different things. I could write all reals. I could do the double R thing. I could also write this in interval notation. What does all reals mean? Every single number that we know. Oh, what kind of infinity? Oh, negative infinity. I hate my infinities. Y'all draw them nicer than me. To positive infinity. But what kind of brackets? Am I hugging or am I bracketing? It's infinity. Can I, you know what brackets are to me? Because I'm a hugger. Brackets are the bear hugs, like the kind that just, those kind of hugs. Can we do that? Can we bear hug infinity? No, because remember, infinity is that guy that's like, get off of me. Move away. Keep moving away. So it's just a little, that kind of hug. I wish y'all could see this. Parentheses are brackets for infinity. Parentheses. Infinity does not like to be hugged. Neither does the dude on the commercial. What's his name? He just cracks me up. I just think he's funny. Yeah, I think it's funny commercial on TV. Just short of a Chuck Norris joke, it's pretty funny. He's the closest thing to Chuck Norris right now, in my expert opinion. What do you think about that? Facile or difficile? Facile. Let's look at another one, because why not? There are those other cases, folks. Maybe. X squared plus 4 less than or equal to 0. Uh-oh. Can we factor that? Nope. We can't factor that, can we? If I solve the corresponding equation, it can't be factored. Yuck. What do I do to solve this? What do? Move it over. Subtract 4. And we get x squared is equal to negative 4. Now what? Take the square root of both sides. And x is going to be equal to, what kind of 2i? What kind? Plus or minus 2i. Huh. Plus or minus. Well, we got solutions, y'all. But can I put them on a number line? It's not invisible. But it's imaginary. It's in a totally different set of numbers. Okay? You cannot put imaginary numbers on a real number line. That is not a joke. If anybody else were to read that line, that sentence, that's not in a math class, they would think it's a joke. That's not a joke. I'm talking about the set of imaginary numbers. I'm talking about the set of real numbers, okay? But I can't put a 2i on a number line because a number line is for real numbers, okay? Can't be graphed. If you get an I, it cannot be graphed. Cannot be graphed, okay? Can't be graphed because of that right there. Y'all cool with that? I'm trying to give you every possibility that you'll see. Nope. How about this one? Last one. So far, we have had these nice little things that just work out, and we've only had how many factors? We've only had 2 factors. I don't guess this would be a quadratic, but we're going to do this problem. Well, how do I know this is not going to be a quadratic? Because there are 3 x's, so it'll be an x cubed, okay? Now, look at that. That's already factored for me, isn't it? So what would my solutions be? My solutions would be 1, negative 3, positive 5. You guys agree with that? Okay. Well, let's go. And we got real numbers, so that means number line. Negative 3, 1, 5. I don't even care if they're equally spaced. Just put the 3 numbers on there. What kind of circles? Open or closed? Open circles at all 3 because they're all the solutions. Now I've got to test 4 numbers. That's exactly right. Test. What number are you going to use less than negative 3? Negative 4. What number between negative 3 and 1? What number between 1 and 2? 5. 1 and 5. What in 5? Oh, it's called subliminal messages. Sorry. Give your teacher money. What about? Give your teacher money. Give your teacher money. What number are you going to choose? I'm sorry. Give your teacher money. What? Give your teacher money. What number are you going to choose past 5? Give your teacher money. This. All right, let's test. I'm glad I have fun. I don't care what y'all do. All right, here we go. What's negative 4 minus 1? Let's just think. I'm not going to show a step. Give your teacher money. Negative What's negative 3 plus 3? 0. Do I even need to go any farther? No. I will. Give your teacher money. But is 0 less than 0? No. I can't darken in my line past to the left of negative 3. Yes, sir. Negative 4 minus, oh, see, that's what I get for skipping steps. Give your teacher money. The, let's just drop back and punt. That is mistake number 6. Okay. Give your teacher money. The, negative 4 minus 1 is negative 5. Negative 1, negative 9. Thank y'all. Dagnabbit. Negative times a negative is a positive. A positive times a negative. I don't even care what the number is. A positive times a negative is a negative number. Folks, is a negative number less than 0? Yes. Shade it in. And then, give your teacher money. Here we go. 0. Golly. Right. Shut up, Cody. I don't know. I'm trying to look above. Daggone it, I'm going to do it again. Thank you. Thank you for being kind in your correction. Number 8. Whatever. Negative 1, 3, negative 5, right? Holy moly. What's a negative times a positive? Negative. Negative times a negative is a positive. So is a positive number less than 0? No. We're not going to shade in between the negative 3 and the 1. Let's test the 2. Isn't this fun? Yes. It's. Aren't you glad you have calculators? Now look, I'm trying to think what number to put where. It is not. No, it isn't. Did I do it wrong again? I didn't do it wrong again. Okay, golly. Stop picking on me. Guys, am I going to get a negative or a positive number? Negative number. Negative number less than 0? Yes, thank God. All right, so darken in where the 2 is. Who knows? That 6 could be. Could be darkened in. 6 minus 1, 6 plus 3, 6 minus 5. Let's check it out. We got 5, 9, 1. Whoop, positive numbers, not less than 0, right? No. All right, so I'm not going to darken in. I've done all my tests. I've tested all my intervals. Now I've got to go, holy moly. How am I going to write interval notation for this thing? Here's what you're going to do. Look at it from left to right. What number is to the very left? Negative infinity to who? Negative 3. Negative infinity gets a parentheses or a bracket. Parentheses. Negative 3 gets a what? Parentheses. We have to join it mathematically, and when we join it mathematically, we use this weird looking U, which represents union. We are marrying that first interval to the second interval. What is parentheses or bracket at 1? Parentheses, and it's going to 5, which gets a parentheses. What if one part has a parentheses and the other side has a bracket? Is that okay? Absolutely, it's fine. We've not worked those, but you are going to for homework, okay? What would it look like? It would look like this. could look like this right here. How would you write interval notation for that? Bracket, 5, comma, infinity, boom. Because I don't have another number, okay? And this could be unioned over here with, what if I had this? 2 and 1. And we're going to union it with bracket 1 to bracket unioned with 5 to positive infinity. If it's infinity, it's a parentheses, whether it's negative or positive infinity, okay? What do you think? Facile, difficile? Okay, you're going to have a worksheet you need to work on. That's your quadratic inequalities. On the worksheet from the other day, what is it, 7 through the end? 13 through what? Number 9. Just saying. Right? Mark it, yeah. I'm even confessing, telling you when to write it down. You're going to have a worksheet on quadratic inequalities. This is not in your textbook. And then finish that worksheet. Don't forget about your test review. We'll go over it at the end of the second half class tomorrow. Tomorrow's Thursday, right? Tomorrow's Thursday. Friday you take your test, so you need to have that finished by tomorrow. That's why I gave you 2 days in addition to everything else. Comprende? All right. Let me give that